Hey guys, let's jump into session number 7 where we dived into the world of advanced retrieval. So, in the past sessions, the RAG pipeline was pretty simple. We would just embed the question, pull the nearest chunk, pass that chunks to the agent, and provide an answer. Well, in this workbook, we'll freeze everything. We'll use the same PDF, same answer model, and change one thing, the retriever. The part that goes and fetches the relevant chunks. And so in this workbook, we built 5 of them. And you can think of them as like a ladder, like each one builds on the next one and kind of adds more to it. So the one we just kind of explained before, which was from previous sessions, was dense retrieval. So here we turned our query into embeddings, and then got chunks, and then that's the retrieval. It's looking for meaning, not exact matches, and so it's very good for semantic search. Then the next step, rung number 2, where it adds best matching 25. So in this one, it's more of an exact word search. Technically, they call it a sparse lexical method, where lexical means matching literal words, and sparse because it scores on keyword overlaps rather than meaning. This really helps if the vector search kind of stumbles on acronyms and kind of misses exact words and abbreviations, because it won't have that semantic meaning, that kind of exact match going on. Then from there we add another layer to improve our retrieval, and that's parent-child. So we search over small precise chunks, the children essentially, as we would in the dense retrieval, but rather than just returning those chunks, we actually then go and get the parents of the chunks. So in our example, we just got the entire page of the children chunks. So this idea means like we search small, but we return large. It kind of allows you for that precise initial matching, but then delivers kind of full context to the model, which can, hold the entire idea and hopefully generate a better response from it. Then from there, we add another layer. So we fuse the dense and the BM25. So we run both, and we call that kind of hybrid search, which allows us, a semantic and an exact search, so hybrid search. And then once we get all those chunks and we combine them, we then do a RRF fusion, so reciprocal rank fusion. This merges 2 ranked lists into one by rewarding items that rank high in either. We then combine multiple retrievers like this to kind of make an ensemble. Then we add a re-ranker, so we add, in this example, cohere, which is a bit of an industry standard, and that rescores our merged lists into a short list. And then lastly, we bring another LLM onto the stage in our multi-query rewrite. So we might have given the agent a kind of vague question, and then we'll get LLM to rewrite it into several different variations of that same question. Then we search across all those variations that the agent made and then re-rank, and it kind of helps if like our phrasing was poor, and can really improve recall. But obviously you're introducing, a new LLM into things, which is another additional cost and more time. So in this workbook, we kind of went through and looked at the additional benefit of kind of adding these rungs together. And the question is, did it earn its place, and is it worth doing? So rather than just guessing and saying, oh, we think this one's the best, we measured it. So there were 4 metrics, and we used a k equals 4, meaning we let each retriever return its top 4 chunks across a few different test cases. So the metrics we looked at, the first was recall at k. So in this one, we're kind of asking the question, did we fetch the right page? Did the correct page show up anywhere in those top 4 chunks? And every retriever we looked at scored 1. They all found the right page. I'm guessing it mainly helps that our corpus is very small and it's well chunked. So in this scenario, recall's not really a separator in helping us decide whether or not adding these extra rungs actually improved our retrieval and our final answer. The second was MRR, so mean reciprocal rank. This measures how high the correct page lands on that list that's ranked. If it's ranked first, it gets a 1, ranked second, 0.5, third, 0.33, a third. It was actually quite interesting to see that the naive dents that we initially started off with and parent-child scored a perfect 1. And the 2 re-rank pipelines actually dropped to 0.778. So the extra resorting that we did in the lower example, like the more complicated retrievers, actually didn't improve our mean reciprocal rank. So the extra resorting steps actually pushed the best evidence down the list. Third was latency, so how long did it take? Obviously time is money in this world. And the parent-child example gave us a response in about 350 milliseconds. The hybrid plus re-rank pipeline that we looked at gave us 53 seconds. Pretty much the parent-child and the hybrid plus re-rank pipeline took 150 times slower because of all that additional steps that we're adding in. And so in that scenario, it really wasn't worth it. And then lastly, we look at faithfulness, and in this metric, we're trying to answer, does the generated answer stay grounded in the retrieved text, or does it hallucinate? Is the answer grounded? The simple pipeline scored a perfect 1, and the fancier ones down here that we looked at came in at 0.944. And we did one of the test cases was looking for acronyms, so BCS and MCS case, which I'll show you shortly. And the more complicated retrievers actually scored poor and got a score of 0.833. This is because the answer drifted past what the source supported. Yeah, so I think looking at this, more making your retriever more sophisticated and adding more machinery to it actually gave it a worse ranking, worse latency, and a slightly worse grounding. With all that in mind, let's jump into the workbook. So, kicking things off, our setup, loading the chunks for naive rag. And then we have our naive dense vector rag, which we've seen quite a few times. Continuing on, BM25, which is, good for exact searches. See, useful for abbreviations, age range, named conditions, and phrases that the dense similarity might not actually catch. And then continuing on. Yeah, so we dive into that here, answering that question. And here we did a bit of a comparison of dense versus BM25, and you can kind of guess that, specific questions like what does the guideline say about BCS and MCS, that would work really well for a BM25 because it does exact searching where we're looking at the acronyms. Might not do as well on the dense retrieval. Whereas kind of those questions that have more vague, slightly, more of a semantic leaning question like what factors shape an individualized preventative care plan, that might do better on a dense retrieval, but you got to look at the numbers. It's very important. So here we kind of inspect both, and I'll just keep scrolling to give you our final answer. So we actually saw that the dense retriever put the best evidence first for the paraphrase heavy and broad multi-part questions, which we kind of expected because it does semantic search. But it did well in the exact terms question. And so it was interesting to see that, whereas we might have expected the BM25 to do better. But because our corpus is quite small, that kind of search, it's not as difficult, I guess, as a way to phrase it. And so it did well in that question. Yeah, we break that down further. Okay, next, moving on to the parent-child retrieval. This was a cool one because, you've got your children, and then you've also got the parent, which in our scenario is just the entire page of the document from that aligns with that, where that chunk came from, i.e. that child. So yeah, we break it up further. Search small, return large. Next, combining that dense and BM25, and then passing into that reciprocal rank fusion and giving us a ranked list. And then lastly, adding rungs to the ladder, stepping up our retrieval. Does it actually benefit things? And so here we add in cohere re-ranking, and so you've got kind of a two-stage retrieve and re-rank pipeline described here, where you get, the dense plus BM25 giving us our reciprocal rank fusion, then getting the parent pages from those child chunks that were ranked, and then passing that on to cohere rank and getting a final context. So continuing on, we did a bit of an evaluation into all of it. Here we've got our numbers that we talked to. There you can see that number of how long it took to do that hybrid RRF, then cohere, compared to all the other ones where, you're adding complexity, you're adding latency to the system. And then continuing on and coming to the final part of our advanced retrieval workbook and answering the question, which retrieval recommendation would we make and why? So my final recommendation is the dense parent-child retrieval. The reason for not choosing the re-ranking pipelines is pretty obvious because of the lower MRR scores, where that extra machinery actually made the ordering worse on the corpus data. There was also an increase in latency from those re-ranking pipelines. And then why not choose the naive dense retrieval and choose the dense parent child retrieval, even though they both got a MRR of 1? It's simply because the parent child will give more information, so you get kind of an entire page rather than chunks split across pages and kind of fragmented chunks that are then passed on to the LLM. So more likely than not, that will actually give a better answer in the future. There is one scenario when I would switch to the hybrid RF then cohere is when there's acronym heavy queries. So I show that here. Yeah. So when you've got those kind of acronym heavy queries, that extra cost can be worth it. But I'd say doing this entire experiment, the optimal of all this is to actually have a routing layer that can choose between what kind of retrieval needs to happen based on the query type. So for general questions, I feel that looking from this workbook, that the dense parent child is sufficient. We don't have that long latency and we get a quick response. Whereas for acronym heavy or exact term queries, well, then the hybrid RF, then cohere, would be a better choice, despite that higher latency and cost. And that's it. I kind of summarize that final decision here as well, where we choose a dense parent retrieval because of its good MRR, its latency, and returns a full parent page. But here, is it an exact term query? Yes. Well then, escalate to hybrid with cohere rank. BM25 allows for that exact term safety net. And so it earns its keep in that scenario. So yeah, I guess a really important point from all of this is don't just add more complexity to your retrieval. Actually measure it, look at the answers, and determine what's best for your scenario. Thanks for listening.